Okay, example 3. First thing I notice about this problem, it says x minus the square root of x minus 12 equal to 0. Back in unit 4 and in unit 6 that we finished, anything dealing with radicals, we knew that problems that had even index values, just like this one does, once you find your solution, you need to check it back in the original problem to make sure it works. So I'm going to make this plain x, the whole x, convert to the radical x. First thing I'm going to do is I'm going to rewrite this x as the square root of x in parentheses raised to a power of 2 minus, I'm going to write the square root of x minus 12 equal to 0. Now I can see that the parentheses both match for both of them. Since the variable x was used already, I'm going to represent the radical x by using the letter a. A is going to represent the square root of x. So now we can break down our problem to become a squared minus a minus 12 equal to 0. Now this is a problem that we can actually factor out easily. So we need numbers that multiply to be negative 12, that add to be negative 1. So when I think of 12, I always think of 4 and 3 to start. And in order to get to negative 1, 1 had to be negative. So the 4 had to be negative. So we can see negative 4 times the 3 is the negative 12. Negative 4 plus the 3s are negative 1. So we break down to a minus 4 times a plus 3 equal to 0. Solve the solution. So we get a is equivalent to 4 and a is equivalent to negative 3. But a was not part of your original problem. A is representing the square root of x. So we're going to substitute back in. Square root of x equals 4. Square root of x equals negative 3. Square both sides because it's a radical, 2. It's a square root of x. Remember, the index is 2, so we raise it to a power of 2. So x is equal to 16 raised to a power of 2. X is equal to positive 9. So we have two possible solutions, x equal to 16 and x equal to 9. So remember, because I said it was an even index, we need to check it. So I'm going to rewrite my original equation, x minus radical x minus 12 equal to 0. I'm repeating it again, x minus the radical x minus 12 equal to 0. I'm going to first test the 16. I'm going to write 16 minus the square root of 16 minus 12. Does that result in 0? Well, 16 is still 16. Square root of 16 is a 4. So 16 minus 4 is 12. Minus 12 equals 0. So 16 is one of our solutions. Now we need to verify if the 9 is a solution. We're going to plug in the 9 now. So 9 minus the square root of 9 minus 12. Does it result in 0? 9 comes down. Square root of 9 is a 3. 9 minus 3 is 6 minus 12. Well, negative 6 does not equal 0, so we do not keep the 9. This is called an extraneous solution. Make sure anytime there's a problem that has an even index, it could be a square root, it could be a 4th root, a 6th root, an 8th root. You need to verify your solutions back in the original to see if it is an actual solution to the problem. Example 4 says 4x to the 4th plus 7x to the 2nd minus 2 equal to 0. This problem right here, we don't really need to use substitution method since the exponent is a power of 4 and the middle one is a power of 2, which means half of 4 is the 2, that is our middle piece. We can go in straight to factoring. So I'm going to put 2 parentheses. And those of you that have had me in the past, I do Colombian method of factoring. So the first step is you're going to take the first solution, the value of 4, and you're going to plug it into both pieces of your parentheses. Power of 4, I'm going to split it in half. I'm going to make them power of 2. That is step 1. Step 1, you're going to take the first coefficient, the leading coefficient, and put it in the parentheses for both of them. And then split the exponent. Step 2, you're going to take the first number and multiply times the last number. And I become negative 8. I'm going to find numbers that multiply to be negative 8 that add to positive 7. Well, the only way to get to 7 and a number of 8 is 8 and 1, where the 1 is the negative. So I'm going to become positive 8, negative 1 inside. We're going to set each of these equal to 0. So we're gonna write 4x squared plus 8 equal to 0, 4x squared minus 1 equal to 0. We're subtracting 8 over. So you get 4x squared equals negative 8. Divide by 4. So you get x squared equals negative 2. Now, because it's negative, and when we take the square root of a negative number, remember, think of it as square root of 2, square root of negative 1. So x is equal to positive and negative I radical 2. That is the first solution. There's two imaginary answers here. You go to the second one, add 1 over. So you have 4x squared equal to 1. Divide both sides by 4. So x squared equals 1/4. If you take the square root of both sides, it means you square root of the numerator and denominator. So x is equal to positive and negative 1/2. Again, the starting coefficient had a power of 4. The variable had a power of 4, which means there should be 4 solutions. In this problem, we actually had 2 answers where it hit the x-axis and 2 values that are floating in the air.